Alright, let's begin to understand NX. Let's first navigate to our working directory, which is x86 Linux, and let's create a new directory called NX, and let's copy our makefile into this directory, and let's also copy our vulnerable file, the C program, not the compiled binary itself. We just want to transfer the vulnerable.c file so that we can compile it by enabling NX. Okay, we also want the jump EAX exploit to be available in this directory. You can actually choose either jump EAX or jump ESP exploit that we have written earlier. It's up to you, but I'm just going with jump EAX exploit. So let me just copy this jump EAX.py into this NX folder. Okay, let's navigate to NX and let's check if we have everything. As you can see, we have all the three files: jump EAX.py, which is the exploit, and we have makefile to compile this vulnerable.c, and the vulnerable program itself. Alright, let's quickly take a look at the contents of makefile. And this is the same old makefile that we have used earlier with the option -z exec stack. Let me quickly show you what this option does to our binary. So let's use make to compile the binary. So we should have the vulnerable binary here. Let's load it using GDB. And let's run a utility called checksec. This comes with Jeff. And if you look at this, NX bit is not enabled. And thus what happens is stack becomes executable. Let's quickly check that. I'm going to put a breakpoint at the beginning. That's a mistake. I just entered twice and there are 3 breakpoints. That's fine. Now let's run the program so that it will hit the first breakpoint. Okay. Now let's type the command vmmap so that we can see the memory map of this process. And if you look at this entry here, the stack is having RWX, which is the stack is actually executable. This is what enables us to place the shellcode on the stack and execute it. Now let's quit this GDB session and let's just double check that our jump EAX exploit works fine with this vulnerable binary. So let me produce the payload. And let's run the vulnerable binary, and if everything goes well, we should get a shell. Let's hit enter, and there you go. So this confirms that the jump EAX exploit is still working fine. So let's quit this shell and let's remove this binary from this directory, and let's quickly make some changes to this makefile. I'm going to remove this -z exec stack. And let me save the file. Let's run make command once again. And this has produced a new vulnerable binary, as you can see here. Now let's once again check our exploit by running the vulnerable binary and passing the contents of payload. If you look at that, the exploit that just worked is now failing after recompiling the program by disabling the option -z exec stack. Let's go ahead and see what happened to this binary using GDB. GDB vulnerable, hit enter. As we did earlier, let's put a breakpoint and let's run the binary. Now let me just quickly clear the screen and let's type checksec. And look at that. The NX entry is now showing it as yes. So NX is enabled. Essentially, that's the only difference in the binary. We have just enabled NX and the exploit is failing. Let's also quickly check what happened to the stack. Let's type vmmap once again and look at this stack. The flag X is missing. So that means the stack is not executable anymore. And our exploit is trying to place the shellcode on the stack, and it is trying to execute that shellcode in a non-executable space. So this is what's causing the problem to our exploit. In the next video, we are going to see a technique called return to libc or ret to libc, which will bypass this limitation to give us a shell. But in a later video, we are also going to use return-oriented programming to actually enable this executable flag on the stack, and eventually we will execute our shellcode on the stack even when NX is enabled. So I hope you have understood how NX works. See you in the next video where we are going to discuss return to libc.